Okay. Now I have shared my whiteboard. Just let me know once you're able to see it. Okay, I've shared it again. Are you guys able to see the screen? Is it visible? Okay, right. Okay. So let's get started. Okay, this is the second chapter. We have discussed logic already. For logic, we only need some tables and we can solve questions easily. Logic is easy. We need to talk about groups. Okay, and when we talk about groups, the basic thing is binary operation. So we have to discuss that as well. Okay, in the previous classes, we have been discussing binary operation and all that. But at that time, I told you for any operation to be binary operation, we need to have 6 properties, right? Now that is correct and incorrect as well. That was important for that chapter, as in I had to explain things that way. But now when I will talk about, when I'll talk about binary operation, group, semi-group, monoid, you'll understand the difference. And this is why I wanted to talk about in depth in this class. Okay, so I will start right now. Okay, now again, for binary operation, we just need to check two things. Okay, that is if x and y belong to set S, x direct y should also belong to set S. And what exactly this is? This is the closure law, right? So what we need to know is that, forget about what I told you already. That is correct. We'll talk about that as well. I'll give a reference to that, that why did I say all that. But for now, just know that if you have a question where you have been asked to determine if, addition is a binary operation in the set of integers or not, you just have to see if you pick up two numbers from the set of integers, the answer should be from the set of integers as well. For example, if I talk about set of integers, I have all the negative integers. I have 0, I have 1, 2, and 3, right? So if I am picking up any two integers, let's say I pick up -3 and 2, what do I get? So -3 and 2 belong to the set of integers, and I'm talking about addition particularly. So this would give me x plus y, that is -3 plus 2, that is -1 belonging to integers. Is it correct? Do we have -1 in the set of integers? Yes, we do. Okay, this is -1. So this is correct. This implies addition is a binary operation in the set of integers. Okay, what I said in the previous classes was correct in some way, but not exactly. Like if I talk about questions, just know if you have been asked to determine if a particular operation is a binary operation or not, you just need to see this. Pick up two numbers randomly from that set, and if x star y, now we're talking about addition, if x plus y is in that set, then yes, this would be the binary operation in that set. Have you understood this?
Yes, ma'am.
Okay. So let's do another example. Let's
मैम ये
say,
चैप्टर 2 है
yes, ये chapter 2 है. And ये particularly वही सब content है जो आप लोगों ने most probably A levels में नहीं पढ़ा हुआ, because when I did my A levels उस time पे ये content नहीं था, right? ये FSC से pertain करता है. Okay. Right. Acha. Let's talk about another example. Let's say I make up my own set. I say that set S has 1, 2, 3. Okay. And now I'm interested to know if addition is a binary operation in set S. Okay. Now this is what I want to know. Okay. Again, what do I do? If x comma y belong to S. So let's take 2 and 3. If 2 and 3 belong to S, what do we need? X steric y belonging to S. What is steric? Steric is the binary operation, that is addition. Like we need to see if addition satisfies this or not. Okay. So 2 plus 3 is giving me 5, and 5 does not belong to this set because 5 does not belong to this set. This implies addition is not a binary operation in the set of in the set S. Okay, in the set S. Now again, I repeat. In the previous classes, I had been saying that we need to check 6 properties. That for now, just know whenever you have to check, you just check this property, that is the closure property. Okay, we will refer to that as well, but let's start off with a new beginning. We are talking about the top chapter groups and logic. We are done with this part already in the last class. We'll talk about it later. यहाँ पे we're talking about groups. अभी we did not start any discussion about groups. We are only talking about what a binary operation is. Okay, so are we clear with binary operation?
Yes.
Everyone?
Yes, ma'am.
Okay. All right. So Asma, are you clear? Ahmad, are you clear?
Yes, ma'am.
Okay. So let's talk about this. So I'll make a table. Okay. So we need 1, 2, 3, 4, 5. 1. Okay. Now we have to talk about Acha. And as soon as we are done with these contents, we'll talk about some past paper questions as well. Okay. Now, what do we have? We have 4 things: groupoid, semi-group, monoid, and group, right? Okay. Right now, we have no idea about what this is. And you have been told that let S be a non-empty set and static is a binary operation. Okay, so for now we know that set S is the set and static is the binary operation, right? So for groupoid we have only one property. I'll explain this again, don't worry. If S is closed with respect to static, okay, for example, we have the set of natural numbers and addition. For example, we have set of integers and addition. Okay, let's talk about groupoid now. Okay. Just like we said for a binary operation, what we need to have is that if we pick up any two numbers randomly from that set, and when we apply the binary operation, in the previous examples, we have been discussing addition only, the answer should be in that set. And that particularly is called the closure property. So that is for a binary operation, right? Is it okay? Is this okay?
And can you
A set
please repeat?
Okay.
in which the closure law is accepted, that's the binary operation, right?
Okay. We will talk about that proper table. ठीक है? अभी के लिए just know for binary operation, we discussed that if x and y belong to the set S, x direct y should also belong to the set S, right? This is what I told you. If this holds, then this direct would be a binary operation in set S. We did two examples. इसमें से एक में static was a binary operation, and then the example in which we had 1, 2, 3 static was not the binary operation. Is it okay now?
Yes, ma'am.
Okay. And now when we talk about groupoid, specifically we are saying if set is closed with respect to static, it is the same thing. Okay, it is the same thing. Again, we're talking about the set of natural numbers. In natural numbers, we have 1, 2, 3, and so on. We have all the positive whole numbers. And we need to see if I pick up any two positive whole numbers, let's say I pick up 10 and 11 belonging to the set n. I know that my binary operation is plus, so 10 plus 11 would be 21. This also belongs to the set of natural numbers. This implies addition the set S with addition is a groupoid, right? Okay. Now I'll give you a quick idea. In this section, we'll talk about different types of groups. Okay. One group is called groupoid, one is called semi-group, one is called monoid, and one is called group. Okay. We will talk about these four groups in this section with these names: groupoid, semi-group, monoid, and group. And for each of them, we have a set of properties which needs to be satisfied. Okay. And you can think about binary operation that way as well, but we have discussed that already. Is it okay this way?
Yes, ma'am.
Okay. Obviously, when I'll explain all this together, that would make more sense. So let's talk. Forget about everything. Let's talk about semi-group. Okay. Let's talk about semi-group. So for semi-group, one thing is that S is closed with respect to this binary operation. And the second thing is static is an associative binary operation. Okay. For example, the set of natural numbers with addition, the set of integers with addition, and the set of real numbers with addition. Okay, now I'll tell you. Again, we're talking about different groups and we need to define them using different properties, right? Here we're talking about semi-group. For semi-groups, what we need to have is that set S should be closed with respect to this binary operation, right? Static. Okay, and then if static is an associative binary operation, then set S would be a semi-group. Is it okay? Please answer me. I want you guys to answer me, to stop me there and then. If you're not able to understand anything, I'm there for you. If you're not understanding all this, just tell me that we are not understanding this. Please, okay?
Uh, can you like explain this in the book again?
Okay, okay. Is everyone clear with the basic idea about what groupoid, semi-group, monoid, and group is? We have different definitions for these things. Okay, we are defining this different way. If a set S is closed with steric, we will give S a particular name, that is groupoid. If it is closed with steric, yes, semi-group is groupoid. And if the steric is an associative binary operation, then this groupoid can be called semi-group. Do you understand it now?
Yeah.
Yes.
Yes.
Yes. Yes, Ahmed?
Understood.
Okay. All right. Okay. Let's talk about monoids. Okay. Now, monoid is again a group, but we need to define that which set S would be a monoid, right? We have a definition. So again, we have S is closed with respect to steric. Now again, if we have this one condition only, we will think of it as a groupoid, because this is the only condition for groupoid which we have. But for a set to be a monoid, we have another thing, that is steric is an associative binary operation. Now again, if we have these two things only, if we have this and this, that S is closed with respect to steric, and if steric is an associative binary operation, we will refer to semi-group, because this is what we have. S is closed with respect to steric, and steric is an associative binary operation. Asma and Faris, are you clear with this?
Yeah.
Yes, ma'am.
Yes. Acha, yes, ma'am. Okay. And the last thing is, now obviously so far it is a semi-group. We need to have something else for set S to be a monoid. S contains identity with respect to steric. Okay. Now this is the different thing. S contains identity with respect to steric, and we have discussed what identity is. Okay. I'll give a quick idea. If, let's say, if steric is plus, we need to have 0 belonging to S. And if steric is multiplication, we need to have 1 belonging to S. That's it. Okay, this is the only thing which you need to understand. Again, we're talking about a set S, which we need to see if set S is a groupoid, semi-group, monoid, or group. Okay, for that we have different definitions. If we talk about groupoids, if any set, if any set that is closed with respect to the binary operation, it would be a groupoid. Perfect. If any set that is closed with respect to the binary operation, and that binary operation is an associative binary operation, it would be a semi-group. And the last one is S is closed with respect to a binary operation, that is steric. Steric is an associative binary operation. And if S contains identity with respect to steric, this would be a monoid. Now, what do we understand by identity? We discussed this in detail, but obviously some students are new. So I'll just give you an idea this way, that if we have binary operation of addition, if 0 belongs to that set, then S contains identity. For example, if I talk about the set of natural numbers with addition, how do we define natural numbers? We define natural numbers n equals 1, 2, 3, and so on, right? And this is very obvious that 0 does not belong to n. This means n does not contain identity with respect to addition. Okay. Now for monoids, what we have is that S contains identity with respect to this binary operation, right? If plus is the binary operation, this one, then I told you just understand the basic idea that 0 should belong to that set. If we talk about this example of natural numbers, we know that 0 does not belong to the set of natural numbers. What does this imply? N does not contain identity with respect to addition. Have you understood this?
Yes, ma'am.
Faris, Ahmed, and Asma, what about you?
Yes.
Yes, ma'am.
Okay. All right. So, sorry, I did this by mistake. Okay. Obviously, I'll give you proper examples in detail. Don't worry about that. Okay. Now let's talk about group. For group, we need again the same thing. S is closed with respect to the binary operation star. Second thing, static is an associative binary operation. Third thing, S contains identity with respect to static. Okay, so far I've not listed down all the properties which we need for a group, but so far what set S can be called exactly? Like, is it a monoid, semi-group, groupoid? What exactly is this? Yes.
Monoid.
Very good. Okay, but you can also call it is monoid because monoid has a set S that is closed with respect to binary operation. This binary operation is associative and the set S contains identity. Okay, but at the same time, it can also be called a semi-group because for semi-group, we have two properties. S is closed and static is associative, and it can also be called groupoid because S is closed with respect to static, right? Okay, but the last property that is going to differentiate a group from all the other sets is inverse of each element of S with respect to static must belong to S. Okay, now again, for a set to be a group, what we need to have is that S is closed with respect to static. Static is an associative binary operation. S contains identity with respect to static. By this, we mean this and this. And the last thing is inverse of each element of S with respect to static must belong to S. Now, if you guys remember, we have discussed this already in the last class. If we talk about addition and multiplication separately, if X belongs to S, minus X should also belong to X. Why? Because X plus minus X will give me the identity element. And if you talk about multiplication, what did we do for multiplication? Yes, anyone?
Like one. No, sorry, divide by
Yes, okay.
it's
So if X is an element of S, 1 by X would also belong to the set S, okay? And if 1 by X belongs to the set S, only then we can say inverse of each element of S with respect to star X must belong to S. So have you understood so far? I will give you examples of everything in detail, but just the basic idea.
Yeah.
Everyone, please answer me.
Yes, ma'am. Got it.
Okay, and what about other students?
Yes.
Asma, Faris, and Ahmed.
Yes,
ma'am.
ma'am.
Okay. Now I'll clear all this and we'll talk about groupoids only. Okay, we'll talk about groupoids only. And don't worry, the questions would be very simple. We'll discuss questions so you will get a better idea. Okay, don't worry about that. Okay. Now I'm talking about groupoid only. What was the criteria? If S is closed with respect to static. Okay, this was the criteria. Now, for this, we need to have a set S and we need to have a binary operation, right? So let's talk about the set of real numbers. Let's talk about the set of real numbers and with this. So what is S? S is R, and what is binary operation? Addition is my binary operation. Okay, we need to know our two things, the set S and our binary operation, and that is and this is how I will see if the set of real numbers is a groupoid or not with respect to addition. Okay, we need to see if the set of real numbers is a groupoid with respect to addition. Okay, this is the discussion going on. What is the criteria for a set to be a groupoid? Yes, guys, we have discussed that. What is the criteria? Asma, Faris, Ahmed, Zahib, please answer me. What is the criteria to have a set as a groupoid? It's written already. If
Should
S
be
is closed with respect to the binary operation, in that case, we will say that yes, our set is a groupoid. Okay. What do we understand by this clause? We know that if X and Y are two elements belonging to the set S, X star Y should also belong to set S. What is my S? My S is the set of real numbers. So I want two elements from the set of real numbers, and my binary operation is plus, such that when I add those two numbers, I get the answer in the set of real numbers. Is it true? Would this be the case in case of real numbers? No, yes, maybe. Please answer me.
Yes, ma'am.
yes.
Okay. So this is 0, this is 1, this is 2, we have 1.5, we have 3, we have 2.5, we have every number in the set of real numbers. Okay, if I pick up any two numbers, let's say I pick up x equals 3 and y equals 10. Okay, so I know that x plus y would be 13 and 13 would certainly belong to real number. Now I cannot check this for every number, but this is certain that if I pick up any two numbers randomly from the set of real numbers, their sum would also be any set of real numbers. So why is it important? Because only then the set of real numbers would be a groupoid. Are we clear with groupoids? Any confusion? Anything that you have not understood?
No, ma'am.
Okay. Then I have a question for you guys and I want you to answer it separately on the chat box. Okay. So the question is, and I'm not doing this obviously to tease anyone, it's just this that I want you guys to understand, right? So and we have ample of time, don't worry. Today we have to discuss these things only. So the question is, if set S is, let's say set S has -3, 2, 10, and 5. Okay. Then is set S a groupoid with respect to addition? This is the question. So I want you to tell me the right, give an answer as yes or no in the chat box. Okay. The criteria has been stated. Okay. So very well done. Okay, Faris is correct. Excellent. And yes, other students, please try doing it. Yes, Ahmed, yes, Asma, and yes, Zahir, please tell me the answers. What do you guys think about it? Is set S a groupoid with respect to addition? Yes. Yes, Zahir, what do you think about this? Just tell me if you have not understood this. I would not mind that. I just want answers. Okay, not really. The product is not in the set. Okay, okay. Very good, Zahib. Excellent. Okay. And yes, what about Asma and Ahmed? I want you guys to answer as well. Please tell me if S is a groupoid. Okay, no, very good. And yes, what about you, Asma? And if you have not understood it, you can tell me directly. I'm not the type of teacher who minds such things. I'm not at all, okay? I do understand that it could be that I'm not able to explain correctly. So I would not mind that. Okay, so I think Asma is not here. That's okay. Okay, so very well said. This set S is not a groupoid, okay? S is not a groupoid because if we pick up two numbers, let's say 10 and 2, so 2 and 10 belong to the set S, but 2 plus 10 does not belong to the set S, right? Okay. And if let's say someone says that, ma'am, what if we pick up -3 and 5? These two numbers belong to set S, but -3 plus 5 also belong to set S. -3 plus 5 is 2. It belongs to set S. But what do we need? We need to think it this way, that if we pick up any two random numbers, okay, it is correct for this, but it does not hold for these two numbers. Okay, so this means that set S is not a groupoid with respect to addition. Okay, are we clear with this?
So which means a set can only be groupoid if the numbers are infinite. Because if it has boundary, the extreme values can be added up and it would be, outside of the set.
Okay, very good. Excellent. Yes, you can say it this way. Very well said. Very good. Bilkul, you are right. You are correct. Yes. So what Ahmed is trying to say is that S, if let's say if S was 1, 2, 3, so on till 10, even in that case, if we add this number and this number, their sum would be greater than the last number, right? This is what he tried saying. But what if I say that the set only has -1, 0, and 1? What about this case? So again, now if we add -1 and 1, we get 0. 0 belongs to set S. If I add 0 plus 1, I get 1. 1 belongs to set S. And if and then you'll be done with all the cases, right? So it is not necessary to have infinite many elements in that set, but for understanding, you said very well that yes, anyone would understood this that way, right? So do you understand through this example as well that if we talk about
Yes.
this S, so S is a groupoid. Why? Because although it does not have infinite many elements, but if I pick up any two numbers belonging to S, I will get -1 plus 0, that is -1, which belongs to S. If I pick up 1 and 0, again I get 1 belonging to S, and if I get 1 and -1 belonging to S, I get 0 belonging to S, right? So this is not necessary to have infinite many elements, okay? Is it okay? So are you clear, Ahmed?
Yes.
Okay, right. Let's talk about the second one now. We have semi-groups. Okay, so what did we write in that table? For semi-groups, we have S is closed with respect to static. That is the binary operation. And the second one is static is an associative binary operation. Okay, this is what we have. Now in this case, if we have a set S, and if that is closed with respect to the binary operation, just like groupoids, and if static is an associative binary operation, in that case, the set S would be a semi-group. For example, let's talk about the set of integers with addition as well as multiplication. Okay, now in order to check the first property, we need to pick up any two numbers, let's say x and y belonging to z, and we want that x plus y should also belong to z. For that, we need to look at the set, okay? Right now in the set of integers, we have all the positive and negative whole numbers as well as 0. Okay, this is what we have in the set of integers. If I pick up any two integers randomly, give me an example. Let's say I pick up -4 and 12, okay? So -4 and 12 belong to the set of integers, and -4 plus 12, that would be 8, also belongs to the set of integers. This means that if I pick up any two numbers randomly, their sum would be in the set of integers. So S certainly is closed with respect to the binary operation, that is addition. Okay, are we clear with the first one? So first property is satisfied. So far we know that S is a groupoid because this was the only criteria for groupoid, right? So far S is groupoid. We need to see if it is a semi-group or not. For that, static should be an associative binary operation. So what do we understand by associative? Yes, anyone? We have done this. What do we understand by associative? Yes, what is the associative property with respect to addition? Please tell me. We have discussed this already.
मैम जब ऐड करते हैं तो उस सेट के अंदर आते हैं इसका आंसर.
Associative. Okay. Basically, it is that let's say if x, y, and z, these three elements belong to the set Z, then x plus y plus z equals x plus y plus z, right? This is the associative property.
Yes.
Okay. Now, if we talk about the second one, what do we have? We have the set of integers with the binary operation multiplication. So, if x and y belong to the set of integers, x multiplied by y should also belong to set of integers. Let's check that out. Again, we have the same set. Let's say we have -4 and 2. So if x is -4 and if y is 2, -4 into 2 is -8, and we know that -8 belongs to the set of integers. This means that if we have any two integers, let's say positive and negative, their product is going to be in the set of integers. So far, the set of integers with respect to multiplication is a groupoid. Okay, either we were talking about addition, either we're talking about multiplication. Binary operation could be any mathematical operation, but we will be discussing addition, multiplication, subtraction zyada, and division less. Okay, addition, subtraction, and multiplication. Okay, right. Abhi we're just talking about addition and multiplication. So the set of integers is a groupoid with respect to multiplication, because abhi sirf pehli property satisfy hogi. Let's talk about the second one. For the second property, we have static is an associative binary operation. So what is the associative binary operation when we are talking about multiplication? Again, it is if x, y, and z, three numbers belong to z, x, y, z equals x, y, and z, right? This is what we are going to have. Are you guys clear with this? So we know that in addition and in multiplication, order does not matter, right? So z is a semi-group with respect to addition, and z is a semi-group with respect to multiplication. Asma, have you understood this?
Yes, ma'am.
And what about other students?
Yeah.
Yes, ma'am.
Okay.
Uh, hello.
Yes.
Yeah, I wasn't paying attention. How is this closed with respect to the set?
Okay. This one?
8 is outside of the set. Yeah.
Okay. No. Okay. Because maybe I have not written it this way, but here we're talking about the set of integers. Okay. We know that in the set of integers, we have all the negative integers. Then we have 0 and we have all the positive integers, right? And we do have -8 as well. Okay. In set of integers, in the very first class, the very first thing was our discussion on different sets. So when we talk
Oh, we
about,
have every number.
yes, in integers, we have every number.
Okay,
Yes.
I thought it was
Yeah, I
the
know.
range was specified.
No. Okay. This is Z and this is for
Okay.
integers. Okay. So is it okay now?
Yes.
Okay, very well done. Now let's talk about the second last set. That is the set of monoids. So we know that again, for a set to be monoid, S is closed with respect to the binary operation. The second one is static is an associative binary operation. And the third one is S contains identity with respect to the binary operation. Okay. Now we have three things. For a set S to be monoid, it should be closed with respect to the binary operation. Binary operation is an associative binary operation, and S contains identity with respect to star X. So we'll talk about two examples. Let's say we have the set of natural numbers with respect to addition, and let's say we have the set of natural numbers with respect to multiplication. Let's see if these two sets are monoids with respect to addition and multiplication. Okay, so the very first property is S is closed with respect to the binary operation. What is our S? Our S is the set of natural numbers. What do we have? Set of natural numbers 1, 2, 3, and so on. All the positive whole numbers. So I know that if I pick up any two positive whole numbers randomly from this set, their sum would also be in the set. So this implies that N is closed with respect to addition, right? Is it good?
Yes, ma'am.
Okay. The second one is static is an associative binary operation. So again, we know that since we're talking about addition, addition is associative. We don't even need to check that. By default, we know x, y, and z belonging to n. So x plus y plus z would be equal to x plus y plus z. Okay. This implies that static is associative. Okay, these things are easy. The new part is the third property. So far, the set S is a semi-group as well as a groupoid because it is closed, so it is a groupoid. It is closed and it has associative property implies that it is a semi-group. For a semi-group to be a monoid, what we need to have is the third property, that is S contains identity with respect to steric. What is steric? Steric is addition. So I told you guys that whenever our binary operation is addition, in order to have identity, we need to have 0 belonging to our set. In our case, we have the set of natural numbers, and we know that 0 does not belong to the set of natural numbers. This implies that n is not a monoid with respect to addition. Are you clear? It is not a monoid with respect to addition, but you will see different over here. Okay, is it okay for addition? Have you understood everything?
Yes, ma'am.
Okay, now I want you guys to again check this out and tell me if n is closed with respect to multiplication or not. Okay, just check this and tell me the answer. And I want answer from everyone. Okay, please. You can again type in the chat box, direct message me on Zoom.
Maybe third point repeat कर दें.
Okay, this one. Acha.
So it will
Okay.
in chat.
Sorry.
Should we tell the answer in chat or
Yeah, you can tell
to
the
you
answer in chat, okay? Because I want to know from everyone. Okay, but before that, let me just explain. Acha. For semi-group, we only had two things. S is closed with respect to steric, and steric, that is binary operation, is an associative binary operation, right? But when we talk about monoids, we have three properties. The third property is S contains identity with respect to the binary operation. Now, I told you that this is what you guys have missed, although I've shared the recordings, but still, I'll give you a quick recap. Now, let's say we're talking about binary operation, addition, and multiplication. Okay, we only discussed these two binary operations, and these are the important ones. So in addition, the set would have identity if 0 belongs to that set. And in multiplication, the set would have identity if 1 belongs to set, because the additive identity is 0 and the multiplicative identity is 1. Okay, so if we want to check if set S contains identity with respect to steric, we have to see what steric is. In our case, steric was addition. Okay, so what is the important thing? 0 should belong to set S. What is set
Yes,
S? Set of natural numbers. We know that 0 does not belong to the set of natural numbers. This means that n is not a monoid with respect to addition, right?
ठीक है. Yes, ma'am. समझ आ
Okay. Now think about it with multiplication, okay? But before that, just tell me if n is closed with respect to multiplication or not. We're talking about this first property. So I have one answer. Okay, and the answer very well done. Okay. So Emma, this is correct. And what about other students?
Ma'am, S is not closed with respect to steric.
S is not closed. Okay, let's see that. So if we pick up two numbers, let's say x and y, belonging to the set of natural numbers, we need to have x into y belonging to the set of natural numbers, right? Okay, very good. Right. So Asma, look, if I pick up, let's say I pick up 3 and I pick up 10, because in the set of natural numbers, I have all the positive whole numbers, right? Their product would be in the set
होगा
of
ना sir.
natural numbers, right? So if we have the product in this set, this means that S is closed, okay? It is closed with respect to multiplication, right? Have you understood it now?
Yes, ma'am.
Okay. And what about the second one? Yes, again, it is multiplication. You don't have to waste your time. Multiplication and addition are always associative. Okay, just know that. I'm telling you, trust me. X, Y, Z would be equal to X, Y into Z. So this would also be true. This is a bit tricky. I want you guys to check this out. Some of the students have answered this already, but just check the third property. S contains identity with respect to steric. What is S? Set of natural numbers. What is steric? Multiplication. So you need to check something from this table. Okay, just check and let me know the answer. And if you're not able to do it, then I'll do it. Okay.
मैम क्वेश्चन रिपीट करेंगे?
Okay. Now what we are doing? We are discussing monoids. Okay. In monoids, in order to have a set as a monoid, we want our set to satisfy three properties. S should be closed. Yes, it is closed. Steric should be an associative binary operation. Yes, it is an associative binary operation. S contains identity with respect to steric. We need to check that. Okay. What is set?
Yes मैम होगी ना.
अच्छा क्यों होगी? Very good. क्यों होगी?
मैम one है, one set के अंदर one है.
Excellent, because we know that when we talk about multiplication, one is the multiplicative identity and one belongs to the set of natural numbers. So this is 100% correct. Okay, and are we clear with this? कि यहाँ पे it is not a monoid, but n is a monoid with respect to multiplication. Yes, Zahib, Ahmed, Faris, and Asma. Have you understood the difference in both these sets?
Yes, ma'am.
Okay. Any question? Anything that you have not understood so far? We are on the last section now. Okay. So I assume that everything is clear. Let's talk about the last thing now for today, and then we'll talk about some questions. Okay. So we have to discuss groups. Okay. We are talking about groups now. For a set to be a group, what do we need? Okay. We need S is closed with respect to the binary operation. Okay, I'm sorry. Right. So we have S as closed with respect to the binary operation. What is this next property? Static is,
Associative.
yes, very good. Static is an associative property. What is the third one? S contains
Identity.
identity. Okay. With respect to, this is very important. Okay, with respect to static. In last example, S contained identity with respect to multiplication, but it did not contain identity with respect to addition. So ये दोनों चीजें important है. S contains identity with respect to static. And what is the fourth property of groups? That inverse of each element of S with respect to static must belong to S. Acha, okay. Acha, theek hai. Now again, I'll refer to two examples. Let's say we are talking about the set of integers with respect to addition. Okay. Now, so far we just know that this is the set and this is the binary operation. We need to determine if Z is a group with respect to addition or not. Okay. Again, the very first property. I want you guys to tell me quickly that is Z close to addition? Is Z close to is Z close with respect to addition?
Yes.
Yes.
Is there anyone who has no as the answer?
Yeah.
Okay. So Z is closed with respect to addition, because we know if I pick up any two numbers from the set of integers where I have all the negative integers, all the positive ones, -3, -2, I have 0, I have 1, so on, right? मैं कोई भी दो integers ले लूंगी, their sum would be in the set of integers. So this means that Z is closed with respect to addition. So far, this Z is a groupoid, okay? We need to check the second property. Static is an associative property. We know that I've been telling you whenever we have addition or multiplication, without any doubt, you can say yes, okay? That static would be an associative property as long as static is addition or multiplication. Okay? We'll talk about the third one then. S contains identity with respect to addition. Now this is important. So what is the binary
Ma'am,
operation? Binary operation is addition. Yes, who was that?
Ma'am, me, Faris.
Okay, and what are you saying that it is? It has identity or it
Yes, ma'am,
doesn't?
it is correct. Ma'am, it is correct because it contains 0 as well.
Excellent. Very well done. Okay. Since our binary operation is addition, we are looking for 0 only. 0 belongs to Z. This implies that Z contains identity. And last one is a bit challenging. And in fact, it's new, it's not challenging. That inverse of each element of S with respect to static must belong to S. Okay. Now, as I told you for the for identity, just know that this is the binary operation if it is addition. If X belongs to the set, minus X should also belong to the set. If we talk about multiplication, if X belongs to S, 1 by X should also belong to S. This means that if we have minus 4 belonging to S, 4 should belong to S. This means that if I have 1 by 2 belonging to S, okay, I'm doing it this way. So what does it imply? That 2 should also belong to S. So are you clear with the inverses? If the binary operation is addition, we need the negative of every number in that set. For example, if I talk about the set of integers, if I talk about minus 2, I do have minus 2, that is 2. This means I have the inverses of every element in set of integers, even if it is a negative integer or it is a positive integer, right? So the inverse of minus 3 would be 3, inverse of 0 is 0, inverse of minus 1 would be 1, inverse of 1 would be minus 1. I have all the positive and negative integers. This means that I do have all the inverses, right? Is it okay? So for every element in Z, I have inverse with respect to addition, okay? Because with respect to addition, we have minus of that element. Are you clear with this?
Yes.
Yes, ma'am.
Okay. Now, what if I say that this is the set of integers again, but the binary operation is multiplication?
मैम
Sorry.
फिर नहीं होगा.
Very well done. Excellent. Okay. Why? Because again, we have been discussing that Z would be closed. हम कोई भी दो elements देंगे, when we multiply them, the answer would be in Z. It is closed. Okay. So far, Z is a groupoid. Associative होता है with respect to multiplication. I've been telling that. Now it is a semi-group as well. If we talk about the third one, identity element. What is the multiplicative identity? 1. 1 belongs to Z. Even abhi tak it is ठीक है. But if we talk about the last one, we need to have multiplicative inverses, okay? This is multiplication. And for every X belonging to S, we need 1 by X. So अगर मैं कहती हूँ कि for 2 belonging to Z, we don't have 1 by 2 belonging to Z, because in Z we only have whole numbers. What does this imply? Z is not a group with respect to multiplication. So have you understood all of this completely?
Yes, ma'am.
Anything that you have not understood? Anyone?
No, ma'am.
Okay. All right. So since we're talking about group, anything, Ahmed, are you clear? Faris, Asma? Semi-groups, groupoids, monoids, and groups. Is everything clear? I'll share the table with you. Don't worry. Okay.
Yes, ma'am.
Okay. So I'll clear all this and we will talk about some properties of groups only. Okay. Not the properties जिनके through हमें ये पता चलता है कि कोई set group है कि नहीं, but some other properties. We are talking about groups. And we have the first property, that is order of a group. The number of elements of a group is called order of a group, right? So order of a group is the number of elements in group. For example, if I talk about a set which has -1, 0, and 1, so order would be 3. If I talk about set of integers, since we have infinite many elements, we have all the negative integers, we have all the positive integers, so the order would be infinite, but we don't write it this way, right? So order we define only for finite groups. Is it okay?
Yeah.
Okay, right. This is clear. And then The second property is idempotent element. And all this is, by the way, from the syllabus of FSC, which is why all these things are very new for you. So we have, let S be a group, sorry, and A belongs to S, then A is called idempotent if A star A equals A. Okay, now let's talk about that. Okay, first thing is first, order of a group is the number of elements in group. That is easy, and we talk about finite groups only. Okay, अगर कोई group infinite है, like real numbers, like natural numbers, like integers, we say that it is an infinite group. Okay, उसमें they don't ask about order. Okay, and if we talk about idempotent element, so what they are trying to say is that if S is a group, A belongs to S, then A is called idempotent if A star A equals A. For example, if we talk about the set of natural numbers with, let's say, addition, and again, let's talk about set of natural numbers with respect to multiplication. Okay, this is not a criteria for a set to be group. Okay, be very clear with this. We're just discussing idempotent elements. So what they are telling us is that if A belongs to S, let's say we have 0, exactly, we don't have 0 in the set. Let's say if we have 1 belonging to N, 1 plus 1 is not equal to 1, right? So this implies 1 is not an idempotent element, right? This is how we see. Can you think of any idempotent element in the set of natural numbers with addition? Yes? Anyone? Do you think there would be any idempotent element in set of natural numbers with respect to addition, that when you add two natural numbers, you get that answer back? Is that possible? No, it is not. You take 2, 2 plus 2 is 4, 3 plus 3 is 6, 4 plus 4 is 8. So in the case of natural numbers with respect to addition, there is no idempotent element. But again, if we talk about set of natural numbers with respect to multiplication, and we talk about 1, 1 belongs to N, and 1 multiplied by 1 is 1. This means that 1 is idempotent element in the set of natural numbers with respect to multiplication. So is it okay now?
Yeah.
Yes, ma'am.
Anything that you have not understood, any student?
No, ma'am.
Okay. All right. So I think this is good. Now we can talk about some questions. I'll stop sharing this and I will share the questions directly. Acha, the questions are mixed. Some of the questions are from the logic chapter, like this is the same chapter. But since we have discussed that already, so I will not talk about those. Okay, अभी हम सिर्फ group से related questions की बात करेंगे and related to binary operations as well. Okay. So this is the very first question. Okay. Which binary operation is not defined in the set of natural numbers? Now again, we read this question in the last class, but I did not talk about this because I wanted to explain everything in detail, right? In the very first class, we talked about things differently just so I could refer to the first class for this class. Okay? Abhi, we should be clear. We have defined everything. We have defined binary operation. We have defined groupoid, semi-group, monoid, and groups, right? We know that binary operation only needs the closure property. If we have two elements belonging to the set of natural numbers, the answer should also belong to the set of natural numbers. Forget about the inverse thing and identity thing, right? We have that in groups, in monoids, in semi-groups and things like those. Okay, for natural numbers, we know that we only have to satisfy the closure property. Okay, let's talk about addition. Is the set of natural number, is addition a binary operation in the set of natural numbers? If we pick up two numbers, let's say x and y belonging to the set of natural numbers, I know that certainly their sum would be in the set of natural numbers, because what do I have in the set of natural numbers? I have 1, 2, 3, so on. So if I'm adding any two positive numbers, obviously the answer would be in that set. Okay, so this cannot be the answer because we are finding which binary operation is not defined. Okay, so addition is defined. Addition is a binary operation in set of natural numbers. Have you understood this?
Yes.
ma'am.
Okay. If we talk about the second one, I want you guys to tell me, if I have x and y, two numbers belonging to the set of natural numbers, and I do x minus y, is it necessary that I will have x minus y in the set of natural numbers?
मैम आंसर नेगेटिव भी तो आ सकता है.
Exactly.
No.
Answer negative bhi aa sakta hai, very well said. And we do not have negative numbers in the set of natural numbers. What does this imply? That x minus y does not necessarily belong to the set of natural numbers. So this is not closed. For binary operation, we only need the closure property. So B would be the answer, right?
Yeah.
Okay, right. So let's talk about another example. Okay. To each element of a group, there correspond how many inverse elements? We have unique inverses and unique identities, right? We know that 0 belonging to S and 1 belonging to S. These two are the only identities, right? So we have unique identities and we have unique inverses, okay? For -1, the only inverse is 1. For in addition, okay? For 1, the only inverse is 1 in multiplication. For 2, the only inverse is 1 by 2, right? For 3, the only inverse is -3 in case of addition. This means that we have one inverse. So the answer would be only one. Have you understood this? Yes, guys. Please answer me. Is it okay?
Aren't there like two inverses, one for multiplication and one for
No.
addition?
No, look. Okay, very good, very good. But look, when we talk about group, sorry, when we talk about groups, at a time, we have a set and one binary operation. Okay? We only have one binary operation. So, agar I talk about addition only in in case of addition, I know that I have negative numbers, right? So for 3, I will have -3. For 2, I will have -2. For -1, I will have 1. Okay, I have one inverse for each element. Okay, to each element of a group, there correspond how many inverse elements? One only. It's very clear. Okay, if we talk about 3, we have -3. If we talk about 2, we have -2. For each element, we have one inverse only. Is this okay?
Yes, ma'am.
Faris, have you understood this?
Can you repeat the question? I actually slept.
Oh, okay. Right. So the question is, to each element of a group, okay, we have a group, we have a set which is satisfying all the properties of groups. There correspond how many inverse elements, right? So we know that in groups we have inverse elements, okay? Now, when we talk about inverse elements, for example, this is set S and this is addition. Inverse with respect to 3 would be -3. Inverse of 2 would be -2. Inverse of -1 would be 1. So her element ka there's only one inverse, right? Only one.
Yes,
So only one would be the answer.
exactly. Okay.
Okay. So
And
is it
what was question number 1?
okay? This is the first question. Which binary operation is not defined in the set of natural numbers, right?
Okay.
So for binary operation, I told you again today that we will look at the closure property only. So if we talk about addition, we know that x plus y belongs to n. Yes, certainly it would be. So addition is a binary operation in the set of natural numbers. But if we talk about subtraction, that is minus. It is very clear that let's say if I have 1 minus 2, I will get a negative number, right? So we don't have negative numbers in the set of natural numbers. So this is why we chose 2, okay? Because we were interested in not. Okay, is it okay now?
Yes.
Okay. So, okay, this is from the logic chapter. Again, logic, 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 logic. Okay. Okay. The set 1 minus 1 iota minus iota is grouped with respect to. Now, I want you guys to answer this question. Think about all the properties we have for the set and then let me know. Okay, take your time. Okay, so far I have one answer only. What about other students? Okay, let's do it together. Okay, I want everyone to pay attention. This is very important question. Now again, the very first thing would be a background to complex numbers. We have been discussing that. Okay, so we know that okay, just give me a second, please. Yeah, this is the question. Okay, again, so we have been discussing complex numbers. We know that iota is under root -1. So iota into iota would be -1. Okay, so this is what complex numbers are, right? The set of 1, -1, iota, minus iota is grouped with respect to, okay, now in this case, what is the first property? That closure law should be satisfied, right? So if I'm multiplying any two numbers, let's say I multiply 1 with -1. Okay, now we need to see with respect to what, okay? Let's talk about addition. If I'm adding 1 minus 1, 1 minus 1, what is the answer? The answer is 0. 0 does not belong to this set. Do we have 0 in this set? Can you see 0 here? No, we cannot. So for a group, we had 4 properties, okay? Number 1, it should be closed. Number 2, associative. Number 3, inverse elements. And number 4, identity element, right? When we talk about addition, clearly we say if we take sum of 2 elements, the answer should be in that set. If we take 1 and -1, their sum is 0. 0 does not belong to S. Closure property is not being satisfied. So this set is not a group with respect to addition. Have you understood this?
Yes, ma'am.
Yes.
Okay. Now we talk about multiplication. So let's say if we have two numbers, if we have 1 and minus 1. When I multiply 1 and minus 1, I get minus 1. I have minus 1, okay? If I multiply 1 with I get I. I have I. If I multiply I with minus I, what do I get? I get minus I square. What is I square? I square is minus 1, okay? So minus 1 into minus 1 is 1. We have 1. This means that closure property is satisfied, right? Is the closure property satisfied? Yes, no?
Yes, ma'am.
Okay. And the first property, that is the closure property, that is satisfied. Associative multiplication is always, that is given. So this would be correct. Third one is identity element. So what is the identity element with respect to multiplication? It is 1. We have 1. So we do have identity as well. And if we talk about the last one, the fourth one, we need multiplicative inverses. So 1 by 1 is 1. We have that. 1 by minus 1 is minus 1. We have that. Okay. Now if we talk about 1 by iota, do we have 1 by iota?
No,
No.
ma'am, because we do rationalization for that.
Yes, very good. So we have to check that through that way, okay? And you will see that we have that in this group. We will check that in the next class. And similarly, 1 over minus iota, okay? We will convert this first to a number, and then we'll see we have our answer in this group, okay? So this would be the answer, but don't worry, we'll discuss this in the next class. Time is up. Any questions other than this question? We'll talk about this in the next class. Anything that you have not understood other than this question? Any concept, any question which we have discussed today, anything?
No,
Sir, I
ma'am.
have a question. I'm saying, sir, teacher, I have questions regarding previous exercise.
Okay, right. So wait, I'll stop the
Which you,
recording.
which you gave as homework, so I can discuss that in private. What's that?
Okay, yeah, that is okay.
Okay.